Alrighty, increasing, decreasing. So what are we going to have to do here to test where the function's increasing or decreasing? First derivative, and we're going to see where that first derivative is doing what? Equal what? 0 or d/e. Good. So you had this topic on your homework, so this is actually a good review for your quiz tomorrow a little bit. You know, this is stuff that you had on your last homework and for which you have a quiz on this material tomorrow. Alright, so anyway, I just saw some people kind of like, you know, like practically falling asleep, so I thought I'd just interject that. Alright, so we need to find the derivative. I wrote down the function again. What does that going to involve here as the overall derivative rule? Quotient rule. Okay, maybe it's been a little while. This f I'm writing is not the original function, just like our fg notation. So this is going to be gf prime minus fg prime over what? Let's start writing that. V squared. Just a quick reminder there. So my g is just x squared minus 4. My f prime is just going to be the constant multiple row 2 times the derivative of x squared minus 9, which is 2x. Okay, so that's the g f prime part. Then it's minus f, which is 2 times quantity x squared minus 9, and then g prime, which is just 2x. All that over g squared, which is x squared minus 4 in parentheses squared. Now before you do anything, you want to think about this a little bit in what you're doing. So we're trying to see specifically where this derivative equals 0 or does not exist. So the d/e part is maybe a good thing to handle for this one right away. D/e is where we're going to have division by 0. So this translates as x squared minus 4, that quantity squared, equals 0. So looking at that, do we have any place that that's going to occur? Positive or negative 2. We've kind of solved that similar equation already, but it's just this one squared. So it'll be the same thing that came up with the domain actually, because it's just a real similar function there. Only difference here is it's squared in the denominator. But we still get these two solutions that when x equals 2 or negative 2, we get division by 0. So these are critical numbers. I'm just going to circle them so they don't get lost in the crowd. Now let's address when we have the derivative equal to 0. So now the bottom part is not contributing to equal 0 solutions. It's the division by 0, which is where d/e for the derivative, right? So kind of make sure you're keeping that straight because that's a real common mistake. So now we're looking at the top. And so the top, notice, we got a common factor there. So maybe you want to take advantage of that before you go crazy and start multiplying things out and expanding, okay? Notice that we have a common factor of what? 2x. Also, we could do a little bit better with 4x. So it's not going to make a difference actually for this one so much. You could, you know, expand it and factor it out, but sometimes it does, so I just wanted to kind of address this one in that way as sort of good practice. And so then we have x squared minus 4 minus x squared minus 9. I'm just going to tag along the x squared minus 4, that quantity is squared, and I'm just going to cross it out because if I multiply both sides of that equation by it goes away and it's not contributing solutions. What's that? Oh, thank you. I forgot to distribute my negative. Thank you very much. Okay, so it's minus x squared and then plus 9 when you distribute the negative things. All right, now simplifying on top. Actually, I can get rid of the bottom, so let's just write it like this. Let's write the whole equation, sorry. I'm lazy. So we have 4x, parentheses, and then x squared minus x squared is 0 actually, so we're left with what? Negative 4 plus 9 is 5. So the only solutions to this are x equals what? 0. So that's another critical value. We use those to set up a table. So the intervals I'm going to pick up at negative infinity on the very left, and then I'm going to go to the first critical value, which is negative 2. Next one in line is 0, so I go negative 2 to 0, 0 to 2, and 2 to infinity. So those are intervals for which we need to test what the derivative is doing, and the character will be the same on that entire interval, so I can just pick one test x value for which to determine what the sign of the derivative is. So some nice values to pick. I'm going to pick negative 3 for the first interval, then negative 1, then 1, then 3. I'm just trying to determine the sign here. So I'm going to, in danger of not finishing this problem again, so these things take forever, it's amazing. Alright, so just believe me, if you plug into the derivative function, these are the signs that you're going to get. You can verify later. We've done this a couple times already. So from this we can tell whether the function is increasing or decreasing. Negative first derivative means that it's decreasing, and a positive first derivative means that it's increasing on that interval. So if you leave your answer in this table form, you will not have to summarize, that's okay. And I will do that to save a little time, to not actually state it. Kind of practiced that before. Part F, local max and mins. All set to use the first derivative test, so second derivative test is really not practical. Where do we have a local max or min in which? At 0. Because the function goes from decreasing to increasing, we have a critical value, and so it's a low point, so we have a local min there. To figure out the y-coordinate, just plug 0 into the function, you get 9/2. So this local min is occurring at 0, 9/2. So finally we have concavity and inflection points. Increasing, decreasing had to do with our first derivative. What does concavity or inflection points have to do with? What do we need to find? The second derivative. Very good. So I'm going to write down the first derivative answer in its nice simple form. We need to find the second derivative, which also involves the quotient rule. So I'm just going to write out the result here, kind of similar to the last one. Except this one, when I'm taking the derivative of the bottom, involves the chain rule. So I drop down the 2. My original inner function is x squared minus 4 with the power of 1, and then the derivative of the inside function, x squared minus 4, is 2x. So a little bit harder in that spot. Then we have x squared minus 4, which is squared. When I square it, we get to the 4th power. So kind of like increasing, decreasing, you want to see where this equals 0 or it does not exist. And those are going to be the borders for the intervals for which we are going to check the concavity. So the D&E thing, let's handle that first again so we don't forget, is going to be the same as before. It's x is equal to plus or minus what? 2. So it's good to get out of the way so we don't forget. Where the second derivative equals 0 is going to be kind of similar. except we got a slightly more difficult function here. But let's do this the way we did before, and notice what can you factor out of the whole entire thing? What's a GCF as it's written? Okay, 20 for example. What else? X squared minus 4. Okay, that's kind of a bonus because if you get that all out, that might be kind of hard to detect later. Or maybe not, but actually it is kind of probably for most of you on this one. So what's behind? We have a factor of x squared minus 4 from the first part. In the second part, we took out the 20, but we got a 4. So this is minus parentheses 4x squared. So it turns out I didn't need those parentheses, but since I screwed it up last time, I was being kind of careful. All right, what do you notice here? Doing some algebra. We got a factor of x squared minus 4 that cancel out, right? So definitely factoring first was, because it was partially factored with the answer to the quotient rule, it's worth their while there. Okay, that 20 could go away too. And so this reduces just to x squared minus 4 minus 4x squared equals 0, which of course we can simplify. So we get negative 3x squared minus 4 equals 0. Okay, let's try to solve here. We're going to get adding 4. We get the following. Divide by negative 3, I get x squared equals negative 4/3. And here I have trouble in paradise, because what happens? Negative under the root. So this is an imaginary line. Which basically means, we're not going to have, we're in real land here. This is for results and theorems for real numbers. So what this translates to is there's no solution in terms of real numbers. So that was a lot of work to say, hey, nothing here. But that's the way it goes sometimes. So we're running out of time, unfortunately. I always look at these and it's like, oh yeah, of course we can get this done in one class period. But I looked at last semester and I didn't either. So, it's just kind of, I'm like, well, I can do it this time. So anyway, I will, what I'll do is I'll do a quick recording to finish it, but I'm going to finish this in class on Wednesday. But it's just, I know you're working on the homework and you might want to see it. So I will finish it and then I'll actually pick up here in the notes on Wednesday as well, or just review it. Okay? All right. See ya on Wednesday.